So on this video, we are going to discuss one of the urea production process, which is the Stamicarbon process. First of all, we are going to discuss what is urea. Urea is a colorless crystalline compound which is the main nitrogenous breakdown product of protein metabolism in mammals and is excreted in urine. It is first synthesized using ammonium cyanate. It is mainly used as fertilizer due to high nitrogen content. Multiple uses in industrial companies, used as resin, used as antifreeze, and used as catalytic reducer. The following is the reaction for the urea synthesis along with the operating conditions. This is the block flow diagram of the process, which will be further explained in the PFD section of this video. This process uses CO2 gas feed as a stripping agent. A countercurrent contact occurs between the output of the synthesis reactor and fresh CO2 gas at the reactor pressure. Strip output enters the low-pressure recirculation section, where the remaining ammonia and CO2 is evaporated, then condensed to form a carbamate solution. The urea solution of the synthesis section only contains ammonia and CO2 at low concentrations, so that the recycled from the low-pressure recirculation section is minimized. The urea solution output from the recirculation section contains 75% urea heavy, concentrated in the evaporation section. The process condensate comes from water evaporation in the evaporation or crystallization section, containing ammonia and urea. Before this condensate process is cleaned, urea is hydrolyzed into ammonia and carbon dioxide. Then it is stripped with steam and returned to the urea synthesis via the recirculation section. In the CO2 preparation section, it is known that the CO2 feed contains hydrogen. The hydrogen is removed by using a catalytic reaction. The CO2 gas is then taken into a centrifugal compressor. There are a few key points in the stripping section, which are that it uses a falling film stripper and it transfers ammonia and carbon dioxide into gas phase. The medium pressure steam decomposes ammonium carbamate into ammonia and CO2. The CO2 is used for stripping medium. The low temperature is used in order to minimize the corrosion, and a gas containing ammonia and CO2 are taken into the high pressure condenser. Condensation of ammonia and carbon dioxide gases leaving the stripper occurs in the high-pressure carbamate condenser at synthesis pressure. Besides condensation, also chemical formation of ammonium carbamate from ammonia and carbon dioxide takes place in the condenser. Because of the high pressure, the heat liberated from the condensation and subsequent ammonium carbamate formation is at high temperature. This heat, therefore, can effectively be used for the production of steam for further use in the urea plant itself. The condensation in the high-pressure carbamate condenser is not affected completely. Remaining gases are condensed in the reactor and provide the heat required for the dehydration of carbamate, as well as for heating the mixture to its equilibrium temperature. In this first-generation CO2 stripping plants, the high-pressure carbamate condenser was of the vertical falling film type, the condenser liquid carbamate flowing down along the inside wall of the heat exchanger tubes. In the purging section of nitrogen and oxygen, the oxygen and nitrogen gas mixture from synthesis section are removed of ammonia and high-pressure scrubber and low-pressure absorber and then purged. The gas mixture is washed in the high-pressure scrubber with carbamate from low-pressure recirculation. In the low-pressure circulation section, ammonium carbamate is decomposed to obtain carbamate-free aqueous urea. Waste is recycled as aqueous ammonium carbamate, and the off-gas from decomposition is condensed. And then 75% urea comes from the recirculation stage into the evaporator. Solution is then concentrated by evaporation. The process condensate from evaporation contains ammonia and urea. Urea in condensate is hydrolyzed into ammonia and carbon dioxide. ammonia and carbon dioxide are taken into low-pressure recirculation stage. That is all for the Stamicarbon process. Thank you for watching.